Hello. So, today we will discuss another aspect of cloud computing, rather another companion technology where cloud computing can be an enabling technology to have better services and better delivery of the services, right. So, that is what we will discuss today about IoT cloud. So, as we know that IoT is a buzzword, that is Internet of Things, right. So, that means anything, rather anything and everything is now becoming internet enabled. So, that may in other sense that there are sensors as we see in a sensor cloud also, and there can be other type of different variety of sensors which are enabling it to be connected to the internet. So, anything and everything is connecting to the internet, and there is a huge volume of data, different variety of services which are being possible with this sort of mechanisms. So, we like to see that this IoT cloud, that is amalgamation of this cloud technology or cloud philosophy with this IoT, how it is likely to help the overall performance of this these services of Internet of Things or cloud services. So, if we look at the motivation is clear that increasing adaptation of sensing technology, RFID, cameras, mobile phones and everything and anything and everything. So, sensor devices are becoming widely available across different type of mechanisms. So, when we talk about sensor cloud, we are more concerned about that the sensing device itself. Here it is what we are looking at, these are sensing devices which are ubiquitously available. So, there may be very thin line between the things, but it has a different way of handling, and most of the cases are more application oriented type of things. Like wireless sensor network or technology play a vital role in bridging the gap between physical and virtual world. So, it helps us to take the physical world to the digitized world and enabling things to respond to change to their physical environment, right. So, I say that my AC will be air conditioning system will be changing based on the temperature of the things, right. The temperature sensor activates the air conditioning process, or it increases or decreases the temperature, or the air conditioning controller system is being controlled or being activated by these sensors. So, this sort of activities where the sensors in turn activating some other things. So, those type of things are there, right. So, what we see that sensor collect data from their environment, generating information and raising awareness about the context. Like we see here, there is a variety of sensors, right, variety of so called objects or things, and they are having different sort of connectivity, sometimes wired or mostly wireless with this rest of the things, right. So, sensors in a sense is a like for example, sensor in electronic jacket, a person wearing a electronic jacket can collect information about changes in the external temperature, and the parameters of the jacket will be sending, like the jacket may heat up appropriately based on the fall of temperature and so forth. So, Internet of Things as we hear about it for in our every literature talking about whenever we talk about sensors and other things, extending the current internet and providing connection, communication and internetworking between the devices, that is the physical objects or sometimes called things, is a growing trend and often referred to as IoT or Internet of Things. So, it is a scenario in which objects or people are provided with unique identifiers, that means has been identified, and the ability to transfer data over a network without requiring to human or human to computer interaction. So, that means these devices are enabled itself to communicate data to the internet, so called, right. So, a thing in the internet can be a person with a heart monitoring implant, or a farm animal with a biochip transponder, or a automobile that is built-in sensors to alert driver when the tire pressure low, or it is some malfunctioning some of the any devices, or it can be a natural or man-made object that can be assigned an IP address and so on and so forth. So, that something that is uniquely identified. IP address may be one of the mechanism to do that, so that it can communicate with these unique things, right. In case of a sensor, normal sensor deployment, I may not have a unique identifier. I am more concerned about the data which is going to the things, right. I am more concerned about here, though the data is important, but I can uniquely identify a thing or a object. So, technologies and solutions that enable integration of real world data and services into current information networking technologies are often described under the umbrella term called Internet of Things, right. That is the core of the whole thing. So, day to day so called more objects or more things are being connected, right. So, we see starting from vehicle to some of the devices in a lab, or even some filtering mechanisms, or a lighting systems or lights, right, which are based on the things, may be controlled by the things, all are communicating in case of a smart grid or so, and this access control and lot many things, right. So, home daily life devices are getting connected, businesses, public infrastructure, healthcare, and etcetera, etcetera. So, it is a long list, and every day things are being enabled. So, we have the ability to control the devices, actuate some other devices based on the sensed by some other applications, and so on and so forth. So, here it may not be always sensing. So, it is I can have it to actuate a thing, like I can say have a controller circuit which is being actuated by something, by external things, like I switch on the lights, switch on the fan, or activate something by using a application on the mobile, but the light or the electric switch is being is a thing, or is a IoT device, where it acts as a IoT device, right. So, it is not exactly sensing in that terms the environment, but in terms it is being activated by a through a internet. So, it is in other, say I can say anytime, any place connectivity for anyone and anything. So, something like that, right, anytime. So, any place, location, space, time, to anyone and anything. So, any objects and type of. So, people connecting to things, like it is connected maybe to the hospitals, to other type of several mechanisms and type of things, maybe through a mobile device, or it can be things connected to a things, like a car connected to another car, or petrol station, or mechanics, or workshops and type of things, right. So, a particular objects, if it is malfunctioning, or it triggers something to some other network, and so on and so forth, right. Like if it is low on petrol, not only it flashes the message to the driver, also at the same time it searches that what is the nearby petrol or gas station and hooking to the things. Similarly, if it requires a something to be done in the workshop and type of things. So, if you look at the basic IoT architecture, so what it requires on the things, it is the objects or the things needs a gateway, right, to connect to the rest of the world, that is network or cloud and type of things. So, so it is a things, gateway, network and cloud, right. So, whether it is a car or mobile device, a smart watch, or a temperature sensor, or any type of things, right, which can go through a gateway, and connect to the things. So, this gateway provides a connectivity with the rest of the internet, right. It can be cloud, it can be other infrastructure and type of things. So, if you look at, so the devices at the bottom end, so there is a communication path either through MQTT or HTTP, some protocol. Aggregation and bus layer with ESB and message broker. So, aggregation bus layer, so there may be enterprise service bus and sort of things, and message broker. It goes to the event processing and analytics, based on that whatever it sends is goes for event processing and analytics. And there are web portal, dashboard, API management at the top of the layer, right. So, these are different structures. So, these are device manager, these are identity and access management at the across the whole vertical. So, this is broadly a generic or basic IoT architecture, which more or less all devices follows, right. All devices conform to that, whichever, or rather I should say all things, quote unquote things, conform to. So, there are several aspects of IoT systems. One is scalability issue, that scale for IoT system implies that in terms of number of sensors and so on and so forth, if it is increasing, then how to handle. There is a big data issue, that there are so many IoT devices and many of them are having sensing or data acquisition type of things, or even transmitting the data. There is a huge volume of data which need to be processed, and there is a big data analysis and processing issue. And we find a role of cloud computing out here, right. So, that not only in terms of the scaling, in terms of IoT frequently involved use of cloud computing platform, offer potential of large amount of resources, both in terms of storage, data, and also ability and flexibility to scaling operations. So, there is a need for aspects of cloud type or cloud sort of mechanisms. There are few more things, many of the cases it is a real time phenomena. So, the processing etcetera requires some sort of a real time intervention. So, IoT systems often function in real time, data flows continually about events, progress, and there can be a need to produce timely responses to the stream of the events. So, that data being collected, being processed, need to be actuated at a real time. Highly distributed, as we look at that whole lot of devices, a variety of devices, it can span over from a single room to buildings to even to a large much more larger geographical area like a campus or a city and type of things, right. So, it is a highly distributed, and it as it is distributed, automatically heterogeneity come into play, like there can be different objects, different type of devices, and the type of data they transmit or consume, or is there can be a variety or heterogeneity on those type of things. So, IoT systems are often built using very heterogeneous set of different devices and type of things. This applies to sensors to actuator, but also applies to type of network involved in the variety of progress, like some may using Wi-Fi, some may Zigbee, Bluetooth and type of things, and a whole lot of interoperability issues need to be addressed out there, right. So, that in order to address this sort of issue, these IoT gateways are required. So, that it is addressed at a more localized fashion. So, whatever it communicates with the gateway which is more localized fashion, right. So, I say that there are several IoT devices in this room, and I have a gateway which take care of these devices. So, rest of the world or outside the room, they are not bothered about this, how the heterogeneity of the data formats, they are processing mechanisms, the communication paradigm which they do inside the things. The gateway takes care, and the gateway represents the or handles the interoperability or the heterogeneity issue of these IoT devices. On the other hand, we have seen a lot of cloud computing aspects. So, computing enables companies or enterprises applications which are system infrastructure independent to be infrastructure free, that is one aspect. It offers pay as used and on demand services, which is pretty amicable for this type of IoT things. Clients can offload their data and application on cloud for storage and processing, that is there is another, these are the issues which provides. And as we have seen already that there is a number of applications or number of features of cloud, right, like mobile computing to aspects of security to social networking and so on and so forth. So, cloud computing enables services to be used without any understanding of the infrastructure, right. So, if it is the service provided XaaS type of things, anything say at the SaaS level, it's you don't bother about the what is the underlying infrastructure or the infrastructure or the platform and so on and so forth, works using economy of scale. So, it's as a economy, it's a what we say it works with the using the economy of scales, and it is extremely beneficial for several applications, especially this sort of applications where these IoT type things are there. Data and services are stored remotely, but accessible from anywhere, like as we are seeing that anywhere, anything, anybody type of thing. So, this is again amicable for this IoT operation or IoT paradigm. So, why not then IoT cloud, right. So, that's the things which naturally evolved. It is not like that we we are trying to put them together. It is natural evolution or merging of these two concept of the things. So, there is a wide adaptation and deployment of Internet of Things infrastructure, what we see for various crucial application like logistics, smart city, healthcare, say even parking car parking and so forth. So, this led to high demand on data storage, processing and management in the cloud based data centers, right. So, these IoT devices individually handling will be difficult, and even then you have to have some infrastructure which can handle those things. Why not the cloud, right. Cloud services are mature and provide excellent elastic computation and data management capabilities for IoT, that is it has the potential to give data management capability. In addition, and as IoT systems become complex, cloud management techniques are increasingly employed to manage IoT components, right. So, IoT systems not only the hardware wise, the systems in the processing wise are becoming complex. Cloud services now act as a computational and data processing platform as well as management platform for IoTs, right. So, the cloud platform can very well be a processing platform as well as data management platform for this type of IoT systems, maybe in a localized manner, maybe more globalized manner or on a larger geographical spread or more complex type of situations. So, what we see that integration between IoT and cloud services allows coordination among IoT and cloud services in a seamless way. That is, a cloud service can request an IoT service which includes several IoT elements to reduce amount of sensing data, or the IoT service can request cloud services to provision more resources, etc. So, it is what we say sort of a quote unquote helping each other to provide better services to enterprises, to individuals and other type of services which uses this IoT services. So, if we look at try to look at the cloud components for IoT. So, there are, you can see there are several verticals. One is the user layer, where in the end user applications or IoT users are there. Then we have a proximity network, right, which are more near to the this user layer. There are sensor, actuator, agent, firmware, network connectivity, user interface devices and so on and so forth. Here we have this IoT gateway, which connects this part with this public network. So, the IoT devices or applications which are connected by the proximity network, which can be again having heterogeneous type of things, different IoT devices can do can connect to the things. This IoT gateway connects to the rest of the world. So, PR cloud, through a PR cloud to the other type of things. So, what it goes that the application logic, analytics, agent, device, data store, this IoT gateway connect to this maybe a DNS system or a content delivery CDN, firewall, local load balancer and type of things. So, this in turn connects to these things, which connects it to the provider cloud or a CSP, cloud service provider, which has all its cloud components, right. Already we know that can be a device registry, device management, API management, which are there in that IoT cloud. So, application logic, which helps in doing analysis, analytics, where the analytics data repository, cognitive applications or cognitive mechanisms, actionable insights, streaming computing, all these analytics related things can be there, right. And these in turns can connect to a enterprise network, right. So, it has a user directory and so on and so forth. So, if you see there are different layers. So, user layer, proximity network, through a gateway connected to the public network, this connects to a provider cloud, and if required it goes to a enterprise network for accessing other type of services, right. Like I say that I have a car which detects some anomaly, it uses some gateway to connect to the cloud, it with different type of not only from different data from the cloud, other environmental data, this does some analytics, then it may trigger to that particular car manufacturer or car related service provider or workshop, and goes to that enterprise and then gets a feedback and so on and so forth, right. So, make some what we say corrective actions on the things, like providing maybe a service vehicle or sending alert to the driver and so on and so forth. So, this can be there can be this sort of aspects. So, there is ICOMOD. So, one it is from particular one publications and IoT cloud systems, where we see that different layers, right. At the top layer represent the typical IoT application executed across IoT and clouds, right. So, it is the top layer, which is a typical lightweight analytics and control, large scale data analytics. So, this is at the top layer. The bottom layer middle layer represent the software layer as an IoT system built on the top of various type of cloud services and the IoT elements. So, this is the middle layer, where the sensors, the gateways, on the IoT cloud side there is a load balancer, event handler, message oriented middleware, and there are other cloud related databases, there are NoSQL databases, near real time or real time data processing. At the bottom layer shows the different tools and services from ICOMOD, that particular framework that can be used to monitor, control, configure the software layer. So, this is more for deploy, configure, govern and control at different type of services. So, this is a typical one example of an IoT cloud system or IoT cloud framework. So, there are if we look at the infrastructure protocol and software platform for enabling an internet of thing cloud systems. So, infrastructure wise in IoT industrial and common gateways, for example, Intel IoT gateway may be thing, and operating system containers such as Dockers, these are aspects. In case of a cloud, virtual machines and operating system containers. So, purpose is to enable virtual machines where software components will be executed, right. So, connectivity protocol, MQTT, that is message queue telemetry transport, constant application or COAP, HTTP, different protocol which is there in the IoT for connectivity protocol. In the case of cloud also we have MQTT, AMQP and HTTP and so forth. The purpose is enable connectivity among IoT elements between IoT part and the cloud services. So, this connectivity protocols allows that how connectivity will be there. There are platform software services which enable core platform services for IoT and cloud tasks, and we have different type of services. There are lightweight data services, whereas there are load balancers such as HA proxy and so forth. So, that means, if we look at the different types of infrastructure protocol and software platform which are there is a coupling between this IoT and the cloud to have a unified vision. So, there is a small example that developing vehicular data cloud services in IoT environment. So advancement in cloud computing and IoT have provided promising opportunity to resolve challenges caused by the increasing transportation issue. So, transportation worldwide is a major challenge, that how to have safe driving with proper traffic management and so forth. So, a multi-layered vehicular cloud platform by using cloud computing and IoT technology has been presented in this work. To innovative vehicular cloud services like intelligent parking services and vehicular data mining cloud services for vehicle warranty analysis, etc., are some of this motivating example. So, if we look at that, one side this IoT things are there, it is this is architecture IoT based vehicular data cloud. So, different sensor, actuator, GPS devices, smartphone and other internet services, and we have things like street lights, utilities, smart metering, roadside infrastructure and so forth. So, these are different IoT devices. On the other hand, we have this cloud like remote diagnosis, traffic, geographical information system, SAS, PaaS, IaaS and other things. So, we have a middle layer like which allows this communication technology like satellite network, if it is communication, wireless network like vehicular ad hoc network, 3G, 4G services and internet. So, this is allowing, this is enabling this merging of information between these IoT devices and cloud for proper decision making, or what we can say that meaningful decision making or some sort of a real time or near real time decision making. So, if we look at the services of IoT based vehicular data clouds, so there are network and data services as network and data processing as a service. So, this is a new type of service, like vehicle provides their networking and data processing capability to other vehicles through the cloud. There can be storage as a service, that is some vehicle may need specific application that require large amount of storage space or a fairly good amount of storage space which is not there in the maybe the OBU or the onboard unit. Thus, the vehicle have the unused storage space, can share their storage like other vehicles. Platform as a service, as a community vehicular cloud offer a variety of cooperative information services such as traffic information, hazard location warning, lane change warning and so forth, what we say in the vehicular ad hoc network terms as a safety related services. So, similarly, another application is the intelligent parking using IoT cloud service. Here also we have several things like starting from driver management by vehicle belts, IFDs, to vehicle to infrastructure, infrastructure to infrastructure communication. There is parking management, monitor, checking, reservation, advertisement. So, there are application model, functional model, communication model and driver model. So, there are different type of modules which are there. So, a particular car can detect by a sensor using it different time stamping that which lane or which lot there is a vacancy and type of things, and before approaching the parking lot, enabling this IoT through gateway to the cloud can find out that where the vacancies are there, right. So, this can be one way of looking at that a application which has a direct implication of our day to day life. So, to summarize, IoT is a dynamic and definitely exciting area. IoT systems are going to be created, more and more IoT systems are going to come, and both domestic, commercial, industrial, health and different context, and it is going to have a large amount of processing, storage requirements, and it faces thus it faces several challenges like scaling up or speed of processing, safety, security, privacy. On the other hand, cloud computing platforms offer potential to use large amount of resources both in terms of storage, processing and have a flexible, scalable processing infrastructure. So, what we see, this IoT cloud platform is going to be a enabling technology for our or several futuristic applications. It may be personalized application to some commercial applications to industrial applications and several type of applications and processing need. So, that may be the next things which is coming into the things, where it encompasses the cloud, IoT, sensors and different aspects of devices or which can communicate and produce data and communicate to the internet. So, with this we will stop here today on this particular aspect of IoT cloud. Thank you.